This video is going to teach you how to convert geometric sequences to exponential functions. So earlier in the year, we learned that a geometric sequence takes the form of a sub n equals a sub 1 times r raised to the n minus 1. We know that a sub 1 represents the first term, and that r represents the common ratio. The common ratio, again, is the number that you are multiplying by to create your sequence. Today I'm going to show you how to go from this form to the general form of an exponential function. So that's going to look like f of x equals a times b to the x power. So a is just going to be a number that will represent our y-intercept. And b is, we're going to call it just the base. Notice that the biggest difference here between these two is that we took the sequence notation of a sub n and rewrote it as f of x. And then in the exponent, we started with n minus 1, but now we're just going to have x. So I'm going to show you how to switch between these. So we're going to go from the sequence to the function. So starting with our sequence, a sub n equals a sub 1 times r to the n minus 1. So the first thing that we're going to do is we're going to go ahead and rewrite. We know a sub n has to be rewritten as f of x equals. And then I'm going to keep everything else the same. So step 1, rewrite in function notation. That's all we're going to do for step 1, and that happened right here. Now, I know, oh, excuse me, this should have been an x. Look at me messing up. So that should be r to the x minus 1. Since we have x in these parentheses, we do have to change our variable, and we know that we have to end up with x. Now, my second step, I have x minus 1 in the exponent here, but I need to have just x. So what we can do, what we learned from our exponent rules, is we can go backwards, and I can take x, which needs to be by itself, and then I'm left with this minus 1, and I can actually break those up into two pieces. I can write each exponent with a base of r individually. So what that's going to look like is we're going to have f of x equals a sub 1 times r to the x, and then another r to the negative 1. So you see, I took each of those exponents and rewrote them with their own individual base. So that's step 2. We are going to break up our exponents. And like I said, this is the product rule in reverse. Now with that, I have r with a negative exponent, so I can rewrite my negative exponent. So let's see, this was where we broke it up, and then 3 is going to be that negative exponent. We never leave our exponents negative, so I want to rewrite that. So I'm going to go ahead and write f of x equals a sub 1 times r to the x power, and then instead of r to the negative 1, that's going to be 1 over r to the first power. And we don't have to write that exponent of positive 1, so I'm going to leave it as 1 over r. So that's here. I'll put a little arrow there. We went from r to the negative 1 to 1 over r. All right. So we're almost there, but I need there to be one number in front of the base to the x. I have my base to the x, but now I've got these two, the a sub 1 and the r. They're both going to represent constants, so I can just go ahead and combine them. And it's going to look like this. A sub 1 times 1 over r is the same as saying a sub 1 over r times r to the x. And so for step 4, we are going to combine a sub 1 and r to make a fraction. So now we have f of x equals something times base to the x. So this looks very similar to what we started with. F of x equals a times b to the x, where we have a, right, a just stands for a number, our y-intercept, where our y-intercept matches up with this first term here, a sub 1 over r. And then r to the x matches up with b to the x, which means r matches up with b. So, like I said, r equals b, and a sub 1 divided by r is the y-intercept. So what this is telling me, excuse me, what this is telling me is that my common ratio is the same as my base. That's not going to change. My y-intercept of any sequence is just the first term divided by the base. Let's look at an example here. I'm going to give you the sequence a sub n equals 45 times 2 to the n minus 1. I'm going to show you how we do this with actual numbers, just to help you understand all of the steps. With all the letters, it's a lot harder to understand. So, step 1 is going to be to rewrite in function notation. So I'm going to go ahead and write f of x equals 45 times 2, and then instead of n minus 1, it's going to be x minus 1. My second step was to go from x minus 1 to r to the x and r to the negative 1. So f of x equals 45 times, now we're going to break this up into two pieces, 2 to the x and 2 to the negative 1. Step 3 is to take care of our negative exponent. So f of x equals 45 times 2 to the x, and then 2 to the negative 1 becomes 1 over 2. And then my last step is to take this first number and that last number and make them into a fraction. So f of x equals 45 over 2 times 2 to the x. And that is my final answer. So what this tells me is that my common ratio in here was 2, right? That's the base at the beginning and at the end. And then my y-intercept is this guy, 45 over 2. And if we're going to write that as an ordered pair, it would be 0, 45 over 2. Okay, so far so good. The more that you do this, the easier it will get. I know it's a lot of steps. However, is there a shortcut? Can you find a shortcut way to get from the beginning to the end? And the answer is, of course, there's a shortcut. Absolutely 100% there is a shortcut. So I'm going to show you how to do that. The quick and easy and dirty way to do this. If you are given something like a sub n equals 2 times 3 to the n minus 1. You know that you have to have f of x equals, and you know that your final thing is going to be the base 3 raised to the x, because that's what it has to be. There's no getting away from that. Like, you know from the beginning that your common ratio is 3. Now, we also know from up here that a is just first term divided by the ratio, right? I know that a, or the y-intercept, is a sub 1 over r. Well, my first term here is 2, and my common ratio is 3. So this is just 2 over 3 times 3 to the x. And that's it. That's the shortcut. You take the first number divided by the second number, and that goes there. And then 3 to the x. And that's it.